This video is going to be about measures of central tendency, which are basically measures of spread and measures of center. So what that means is you've got a whole set of data and you're trying to figure out how spread apart that data is, like a whole bunch of test scores. Are they close together? Did everybody score kind of the same? Did everybody, were their scores all spread out? Some people did really well, some people did terrible. That's the measure of spread. But we also have measures of center, like if you understand the highest and the lowest, where did a whole bunch of people congregate? Was it in the middle somewhere? Those are what are called measures of central tendency. Okay, now 3 of them you should be pretty familiar with. They're things you've been learning about for many years in your lifetime, and those are mean, median, and mode. Okay, so mean is the average. Add them all up and divide by how many numbers there are. Median is the number in the middle. Just put them in order and find the one in the middle. And mode is the most common. Now, if I went through that too fast, there's plenty of examples in the lessons, but they are things you're familiar with. But what I do want to tell you about is how to calculate mean, median, and mode if you're given a table like this. This is called a frequency table. These words still mean the same. Average, add them all up and divide, find the one in the middle, find the most common. But when they're laid out like this, it's a little harder to understand. So this is what I mean. This says that at whatever thing we're doing, there are 5 people who were 10 years old, 6 people who were 11 years old, 8 people who were 12, nobody was 13, and 2 people were 14. Now, finding the mean, the biggest mistake a lot of students want to do is they just want to find the mean of the ages here, these numbers, or the median or the mode of these, like 12 would be the number in the middle, for example, but you can't do that because that's not what the list is. The list isn't 10, 11, 12, 13, 14. The list is 10, 10, 10, 10, 10, because there's 5 10-year-olds, 11, 11, 11, 11, 11, 11. You get it? So really, how many numbers are there here? Because mean is add them all up and divide by how many. So we need to count 5, 10, 15, 16, 17, 18, 19, 20, 21. What we know is that there's 21 total. So when we add them all up, we're going to have to divide by 21. Now, we could just take our calculator and go 10 plus 10 plus 10 plus 10 plus 10 plus 11 plus 11 plus 11 and so on. But that's why multiplication was invented, so that we don't have to add up 10 5 times. We just do 5 times 10. That's multiplication. So this one, it will add up to 50. This one will add up to 66 because we have 11 times 6, 6 11s. Here we've got 8 12s, 8 times 12, 96, no 13s, and then we have 2 14s. That list right there is what we actually have. And that list, we have to figure out the total, okay? The total is the sum of all those numbers. The sum of all these numbers divided by 21 numbers will give us our mean. So add that up real quickly. I've got 50 plus 66 plus 96, 50 plus 66 plus 96 plus 0 plus 28. 240 is our total, and we had 21 numbers. So our mean is 11.42. Okay, unless I tell you differently, it's always a good idea to just round your mean to the nearest tenth. So I'm just going to round it to 11.4 unless the directions say differently, or if on a standardized test like an EOC, an MCA, a SAT, ACT, whatever standardized test, if your multiple choices are to the nearest tenth, then round to the nearest tenth. If your multiple choices are to the nearest hundredth, then round to the nearest hundredth, and so on. Okay, so I got 240 by doing 5 times 10, 6 times 11, 8 times 12, and so on, divided by 21 numbers. That's my mean. Now, my median, there's 21 numbers. You don't have to line them all up and start crossing them off and get the one in the middle. All you really have to do is know that if there's 21 numbers, count in your head, count off 10, count off 10, there'll be one left over in the middle. So we have to count off 10 from each end. 5, 6, 7, 8, 9, 10. That's the 10th one. So this is the 11th one. 5, 6, 7, 8, 9, 10. This right here that I circled, this data point will be the middle data point, because if you see, I've got 5, 10 of them that are smaller, or to the left of it, and 5, 8, and 10 of them that are to the right of it. That means that 11 is in the middle. And the mode is still the most common. There's 8 12s. There were only 6 11s, so 12 is the most common number. That is how you find your measures of central tendency on a table. Now, there's more than just that, though. Those are your measures of center. What about our measures of spread? Well, our measures of spread are the range, Q1, quartile 1, quartile 3, interquartile range. Okay? So what I'm going to do is our range is just our max minus our min. Looking at our table, our maximum is still 14, our minimum is still 10. Oldest kid there was 14, youngest kid there was 10, so 14 minus 10 is 4, so that one is still the same. Just subtract. Okay, now quartile 1. Remember that Q1, the first quartile, is the middle of the numbers on the left of the median. The middle of the numbers on the left of the median. So at this point, you can decide to just do it the same way I did. This was the median. So I have 10 numbers to the left. So that means I have to go to the 5th number. The 10th number really is going to have 5 to the left and 5 to the right. So we need to have the number that's between the 5th and the 6th number, which is, this is the 5th number, this is the 6th number. So it's between 10 and 11, which would be 10.5 for Q1. Now we are actually going to check this to make sure that it worked. Q3, again, we need to have, if this is the median, we need to have, there's 10 numbers here. We need to have the number between the 5th and the 6th. And the 5th number is 12. The 6th number is 12. Between 12 and 12 is still 12. So our Q3 is 12. Our IQR is our interquartile range. That's Q3 minus Q1. So 12 minus 10.5 is 1.5. And then from that, we can find out if we have any outliers. We can determine whether or not 14 is a statistical outlier or if it just appears to be that much bigger than the rest of them. Really, 12 is not that much bigger than, 14 is not that much bigger than 12, but in this data set, everything is kind of grouped between 10 and 12 with only 2 numbers of 14 that are out there. But usually when there's more than one that appears to be bigger or smaller than the rest, it's not an outlier because there's more than one. An outlier is statistically one number that's way bigger or way smaller. But we're still going to calculate it because we know a formula. So our outlier formula is, what we're going to do is we're going to take our 1.5 times our IQR, 1.5 times our interquartile range, which our interquartile range was coincidentally 1.5. That's a total coincidence. So we're going to be taking 1.5 times 1.5. Again, that's just a coincidence with the numbers I made up. It has nothing to do with anything that these are the same. 1.5 is part of the formula. My IQR in my problem ended up being 1.5 as well. So 1.5 times 1.5 is 2.25. And from that, what we have to do is we have to take our smallest number, our quartile 1, subtract the 2.25. That gives us our smallest possible value that would be considered okay. And then we're going to do the same thing, but we're going to add it to Q3, and that'll give us our biggest possible number that's considered okay. And then we've got our range, but then we've got our possible numbers that are still considered okay to be within the acceptable range. Okay, so our Q1 was 10.5, so we're going to take 10.5 minus our 2.25, and then our Q3 was 12, and we're going to take 12 plus our 2.25, and those are going to give us our highest and lowest possible values that we will accept. Okay, 10.5 minus 2.25 is 8.25. And 12 plus 2.5 is 14.25. So as long as those values are within this range, this acceptable range, then we are good. And we had two numbers at 14, which are still in this range, so that's okay. And nothing was smaller than 10, so everything has to be between these two numbers, so there are no statistical outliers. And the last measure of spread that we're going to find is our standard deviation. Now, it's a nasty formula, but really, standard deviation means how far apart are these numbers compared to the mean? Okay, let's go back and see what our mean was. Excuse me while I grab this. Okay, our mean was 11.4. So our standard deviation is how spread out are these numbers compared to 11.4? Well, just intuitively looking at these, they all look pretty close to 11.4 minus these two, with the exception of these two. So I'm going to say this standard deviation is going to be pretty small because everything is pretty spread out. I dropped my board just a second. So the way you do your standard deviation is a 5-point process, 5-point process, okay? Since standard deviation definition is how spread out they are compared to the mean, then it makes sense we needed to know the mean, which we already do. But in our steps, we have to find the mean, and our mean is 11.4. Then if we want to know how spread out they are compared to the mean, then we need to subtract them from the mean. Each number in this list has to be subtracted from the mean. Now, this is a pretty big list of 21 numbers, and I have no problems with doing that, but it's just going to take a long time. So in this case, what I'm going to do is just suggest that you go to the website that I gave you for calculating standard deviation, and instead of me actually showing you how to find standard deviation on this bigger list, I'm going to show you how to find the standard deviation on a smaller list. Not because I can't do 21 numbers, but because that's why they invented the calculator to do that. You don't need to have all this time spent on it, but I do want to know that you can do it. So I am going to expect you to be able to do it without a calculator, but let's do it with a more reasonable set of numbers. Now, we were going to expect that that list was going to be a pretty small standard deviation, and I do challenge you to put that into the calculator that I gave you in the lesson. But I'm going to show you in a different set of numbers. Let's say my values are 10 and 14, because those were the ages, the youngest and oldest of the group. But let's say that there were also a 19-year-old and a 12-year-old. Okay? So these are our 4, and we want to find the standard deviation. All right, number 1, we are going to find the mean. Add these up and divide by 4 because there are 4 numbers. Now I'm going to make a prediction here. I don't know what the mean is yet, but these numbers seem fairly spread out compared to the last list for sure. 10 plus 14 is 24, plus 19 plus 12 equals, divided by 4 equals 13.75. We'll go ahead and leave that at 13.75 since it is a discrete number and it doesn't continue on. Okay, so then what we have to do, step 2, subtract each number from the mean. Subtract each number from the mean. Okay, find the mean, then subtract each number from the mean. That's step 2. So I'm going to take 13.75 minus 10. 13.75 minus 10 is 3.75. Then I'm going to take 13.75 minus 14, but I'm going to do it in the other order so it stays positive. 14 minus 13.75 is 0.25. Again, I'm going to subtract it so that my answer is positive. I'm going to go 19 minus 13.75, which is 5.5. And then 13.75 minus 12, again, do it so it's positive. I have 1.75. Okay, that is subtracting each number from the mean. Step 3, now we have to square all of these numbers, okay? Square all of these numbers. So I'm going to take my calculator. Now I'm going to go 3.75 squared, which is 14.0625. What I'm going to do is, I'll show you, square each number. is the next step, but I'm not actually going to write down the squares. I'm just going to put a little square here and leave that number on my calculator, because the next step, I'll show you all of it at once. The next step will be to find the new mean. And so instead of writing down all my squares, I'm just going to do this. I'm going to put a little square by each of those to show you that I'm squaring all of them. But then since step 4 is to find my new mean, which means add them all up and divide, I'm just going to do this. I know that I'm going to have to add these all up. So I'm going to put that into my calculator instead of writing down all those steps. So I already have the 3.75 squared plus 0.25 squared. Now you don't have to clear your calculator if you're doing that, because we're going to end up just getting our total here and then dividing by 4 because we had 4 numbers. Then plus 5.5 squared plus 1.75 squared. I get my total. You want to push equals, find the new mean. I get my total, which is 47.4375. I had 4 numbers, so now I want to divide by 4. And I get 11.85 is my new mean. My old mean was 13.75. My new mean is 11.85. That number, that 11.85 is what's called the variance. Now, that's a vocabulary word you're going to want to know, but we're not going to really use it much. But the variance is what you get. It's basically the new mean of the samples. Once we found the mean, subtracted them from the mean, then squared them and found the new mean. The variance is that new mean. But the last step is to take the square root. And that will be the standard deviation. So the square root of the variance is the standard deviation. Answer: square root of my 11.85 is approximately 3.44. You can leave it at 3.4 or 3.44. That is my standard deviation. I didn't calculate the standard deviation of the original set, but I would have guessed it was smaller than 3.44, only because this 19 makes this pretty big. In fact, we could calculate it as a statistical outlier, and you could try that and see if it is or if it isn't. But that is measure of center and spread using a table, except for I was stout and didn't do the measure of spread on the table. This is the standard deviation because there were too many numbers. So that's okay, because you don't have to. So I just have 2 more examples, but this is getting long, so I'm going to stop it and give it to you in another one. So there you go.